Just a question here that uses the idea of arithmetic and geometric series, come from a tuna paper. Cards are stacked, building a house of cards, and they've defined a house of cards as 3 cards to make a house. So the top one has got 3 cards, then the next row there's another 2 houses in there, and then the next row there's 3 houses in there, and so on. First question was simply show that a house of cards with 12 rows has a total of 234 cards all up. The first house of cards would have 3 cards in it. The common difference then would be 3, because we're not saying how many cards are there altogether, it's just how many cards are in the row of the house of cards. So in the second row there would be 6 cards. Plug it into our formula and we get our answer. There it is, 234. This time they've told us how many cards there are altogether. The question is how many rows were there? Sum to n, all of them, are going to add up to be 828. We want to know what n is. A and D hasn't changed, and we get a quadratic. Solving a quadratic, 2 possibilities, but of course for our problem the negative answer doesn't make sense, so therefore we know there's 23 rows in our house of cards. Company sales, they're not doing too well, it's declining 6% every year. We know in 2001 there were 50,000 items sold. So during which year did the sales fall below? 20,000. First term's 50,000. The ratio, of course, is not 6%, it's declining by 6%, so the ratio is 0.94. And we want to know when the general term is less than 20,000. So let's plug it in, and we've got the exponential inequality to solve. Play around with it. Now, logs will get that power out of there. And of course we always remember if you're dividing by a log of a number that's less than 1, that's actually a negative number. So we flip the sign and we get n has to be bigger than 15.8, therefore it happened in the 16th year. So 2016. Explain why this geometric series does not have a limiting sum. Well, the key to limiting sums, we know the ratio has to be in between -1 and 1. So what is the ratio here? It's 1 over root 2 minus 1, and that's bigger than 1. Comes out to be around 2.4. So no, there's no limiting sum. Here was probably one of the more difficult questions for a tuna paper anyway. Consider the series 1 minus tan squared theta plus tan to the power of 4 theta, etc., etc. So when the limiting sum exists, what they're basically saying is sometimes this will have a limiting sum, sometimes it won't. So when it exists, find the value of that limiting sum. A is equal to 1. The ratio is minus tan squared theta. And we know the limiting sum, or sum to infinity, is A on 1 minus R. We'll get 1 on 1 plus tan squared theta, which is cos squared theta. So if it does exist, we know it'll be the cos squared of theta. So what values of theta then does this limiting sum actually exist? And they're saying it has to be between minus pi and 2 and pi and 2. So again, that ratio has to be in between -1 and 1. So minus tan squared theta is in between -1 and 1, which means tan squared theta, we flip the signs because we're dividing by -1, but actually we still end up between -1 and 1. But now we'll find the square root of both sides. Well, you can't find the square root of -1, but you'll get that tan theta is in between -1 and 1 anyway, because the square root of 1 is plus or minus 1. So when is tan theta in between -1 and 1? Well, we know it's equal to plus or minus 1 at plus or minus pi and 4. If you think of your tan curve, what are we saying? Well, there's our values. They will be minus pi and 4 and pi and 4. But look at our graph, we can say, well, theta would have to be in between those values. So that's just some questions on using our arithmetic and geometry.